In this video, we will learn why is the derivative of a constant function equal to 0. Okay. By derivative, what we mean? Derivative is simply equal to slope. Okay. So derivative is equal to slope. And slope is simply rise upon run. And what does this actually mean? It simply means if we have a graph like this, okay, and if on this axis, this is the x-axis, this is our y-axis, and let us say we have a line, okay, the slope of this line is being given us. Let us say we have 2 points, this point and this point. Slope of this line is simply equal to change in the vertical distance, okay, that means uh, from this point to this point, what we call del y. Okay, this denotes the change in the vertical axis upon the change in horizontal axis. Okay, so horizontally we are at this point. Okay, so this distance is denoted by, let us say, del x. Okay, this is the basic notation of the slope. Slope is simply rise upon run, that means change in y, that is change in y upon change in x. Okay, and what about a constant? This is the slope of a line. Okay, and a line of the form mx plus b. Okay, and its slope will be equal to m. Obviously this b is the intercept. What about a constant? Let us say we have a function y is equal to 5. This is the question that has been asked, why the derivative of a constant is equal to 0. Okay, how can I draw the graph of this function? And let me draw the graph of this function here. Okay, so we have x-axis, y-axis. Okay, so this function can be written as y is equal to 5 times x to the power 0. Okay, so writing 5 or 5x to the power 0 is same, because x to the power 0 is equal to 1. That means anything raised to the power 0 will be obviously equal to 1. Okay, by anything we don't mean x is equal to 0, so 0 raised power 0 is undefined. So I can write this y is equal to 5 x to the power 0. Okay, now if I want to draw the graph of this line, the graph will be simply a straight line, a straight horizontal line. Okay, and its intercept is 5 here. Okay, why? If x is equal to 1, let us say when x is equal to 1, if I write here when x is equal to 1, in this equation our y will be equal to 5 into, in place of x we have 1 raised power 0, and it will simply equal to 5. If x is equal to 2, okay, our y will be equal to 5 into 2 raised power 0, and this is anything raised power 0 is 1, so 5 into 1 is again 5. Any value of x will give us the same value of y. Okay, let us say when x was 1, our y was still 5, and when x was 2, our y was same, that is 5. Now if we apply the above formula of slope, what will we get the slope, or what we call derivative? So derivative is equal to slope, which is equal to change in y upon change in x. Here you can see y has not changed at all. This distance, okay, is 0. that means del y, that means y has not changed when x has changed. So del y is equal to 0 upon, let us say x has changed from 1 to 2, so 2 minus 1 is 1. So 0 upon anything is equal to 0. That's why we say the derivative of a constant function is 5. I have shown it graphically, but what about if I show it in the form of derivatives? I can do that very stuff also here. For that, let me rub this out. Okay. I have explained about the power function rule. That is, if we have a function in the form of y is equal to x to the power n, by power function rule, the derivative of this function will be dy upon dx is equal to, the exponent becomes coefficient n, then we have x, and exponent is subtracted by 1. Okay. Now let's take this very constant function, that is y is equal to 5, and I can write it like this: x to the power 0. As I have told, x to the power 0 is equal to 1, so we are back again with y is equal to 5. If I use the power function rule here again, so dy upon dx will be equal to, so n is 0, so 0 becomes coefficient, so we have 0 into 5 x to the power 0 minus 1, and exponent is subtracted by 1. So this becomes, we have 0 multiplied by any number, it will become 0. That means dy upon dx will be equal to 0. That means derivative of constant is 0. Okay, 0. I hope I make myself clear in this video. Thank you. For more videos on mathematical economics, please subscribe this channel, like, comment and share also. Thank you.